Okay, hi viewers. So welcome back to my channel. So in the previous video I posted ray diagrams for the convex lens. That means in all different positions, when the object is placed in all different positions, how the image formation will get. I will explain. So now coming to the concave lens, not the mirrors. So ray diagrams of concave lens. So two different positions we have, and two different positions how the image formation will occur, we'll find out. So same as the previous measurement, so I'm taking exactly middle this, and first of all this is the convex representation, so curved outwards, arrow mark will be outwards, simple notation. And this one is a concave, this one is curved outwards, so this one is concave curved outwards. So I'm following concave lens, so curved outwards, arrow mark outwards position. Okay, so measurements, if you follow the exact measurement, then we can get the image formation exactly. So I have taken totally measurement of 14 centimeters, up to 14 centimeters I have taken. So up to 14, then exactly middle, that means at 7 I have drawn the concave lens, and this center is called as optic center. This one is called as optic center, and we know this axis is called as principal axis. We know this terminology already. And this one is f1 c1, in the opposite side f2 c2. We know that the distance from optic center to f is double the distance from optic center to c1. Okay, now object at infinity, so I am taking 2 centimeter object, so placing at infinity position and placing there. Infinity means beyond c. So infinity position, how the rays will pass, fall on the optic center. I'm taking 1 centimeter line, that means 2, one above and one below. So let us suppose this is an object. Let us consider this one as object, and how the image will form. See, pass the horizontal rays onto the surface, that means the concave lens. So these are the incident rays. And also one more ray I am taking, same horizontal above the principal axis. These are the incident rays, and also from the below 2, and also at the tip, both. So these are the incident rays, and how the rays will pass from the lens. See, all the, and we know that concave lens means convergent lens. So all what are the rays, incident rays, once it hits the lens optic center, then this will be converged at focus. So this will be the reflected, like this. And also this one, this is the reflected one, and from this position to the f, so this will be the refraction, sorry. And from this down, try to join this one with the dotted lines, that means the convergent position. And this one is the refracted part, refracted ray. And also the last one, this is the refracted, and this is the convergent. So these are the refracted rays, and if you observe, all the rays are converged at focus. All the rays are converged at focus. This is the position, all the position. So what will be the nature now? So nature will be image position, where the image is formed, this is the object and this is the image. Where image is formed is at f1, that is at focus. And highly diminished, that is a point size image. So point size image, so that is highly diminished. and this is appearing in front of the lens, so that is virtual image, and this one we can say erect. Okay, so as at a point size we may not conclude erect. Okay, now coming to the second position, when the object is placed between C1 and F1. So C1 and F1, I have taken 3 centimeters gap, so I'm placing exactly at 1.5. I'm taking 1 centimeter size, height of the object as 1 centimeter. So 1 centimeter HO, that is object size. 1 centimeter I have taken. So same like the concave convex lens. So first thing, you need to draw the horizontal line parallel to the principal axis onto the optic center, and it will be passed through F2 like this. So from F2 it will pass, and from the same top position it will pass through the optic center, like this, and these are the refracted incident rays. But I already said concave means convergent rays, so these are converged. How these are converged we'll see. From this top position on the optic center, we will extend these lines with the dotted lines. We'll extend, try to meet this one, and where these two rays from this, the top one passing from the optic center and also passing through the top of the object, where these two meets, at this position we get the image formation. So this is the image, HI, size of the image. That means when the object is placed between C1 and F1, we got the image, the concave lens at between F1 and optic center. See the nature now. So image position is between F1 and optic center, and it is diminished. If you observe, this is, I have taken 1 centimeter, this is somewhat less, smaller than the object size, so diminished, and this is virtual image because in front of the mirror, virtual, and also it is erect. So this is the explanation for the ray diagrams of concave lens. I hope you understood. We'll see the numericals in the next video.